Hi everyone, welcome to Introduction to Functional Programming. This is a brief introduction video to the course. The language used in this course is Scala. So first we have to become familiar with the syntax before we can do any functional programming at all. So we will go over various concepts several times in order to show you different use cases. Each example will increase your understanding, and in the end you can put all the pieces together. There will be also written exercises for you to practice your understanding, and most of the solutions, by the way, are one-liners, with a few exceptions. So maybe you're wondering, why use functional programming at all? It's pretty much the same reason why we don't code in assembly. We want to make our life easy, basically. It just happens that functional programming concepts do make your life easy, which is make it easy dealing with asynchronous and concurrent systems, help us write concise code, and where possible, we can use the compiler to do proofs. This means that you can ask your compiler to check if a binary search tree conforms, and if not, give you an error at compile time. This is very, very powerful. So how does functional programming give us these powers? Well, it provides us with high-level abstractions that emphasize immutability of data. And on top of that, you also get static typing. So now we're going to go through each one of these. So if you write at a higher level, you don't need to specify how to deal with the low-level issues like common concurrency issues, for example. You can skip worrying about locks, semaphores, and so on. And it allows you to focus on writing the what and not the how. As a result, we can separate business logic from machine logic. In turn, this enhances code readability. And I will show you an example in a few slides. First, let's talk about immutability. How is immutability useful? Let's think about this for a moment. Like, if your data is immutable, you eliminate race conditions and locks. And logic is more easily followed in the code because your data is initialized only once. With static typing, what you get is the fact that you can catch errors at compile time. Like, would you prefer to have your code error at runtime or at compile time? Compile time is much better. And now finally a code example. Which one would you prefer? The one at the top is written in a functional way, and it is much more concise than the second example at the bottom. So notice how in the second example you specify machine logic, which is how to traverse the list, while in the first example you do not need to do this. You code only the what and not the how. So check if all items have property being read, and that's it. You're done. So now maybe you're asking yourself, why does this matter at all? Who cares? And this goes back to the argument about writing in assembly language versus a higher level language. First, you can write better software faster, and as a result, spend less time chasing after bugs, testing the code, and instead we can just focus on the good stuff, which is writing software, right? That's what we want to do. So here's a Scala example I had alluded to a few slides back. The way you should write your Scala code is like you would write a pipeline where you combine operations, which are the what, with operators, which are functions. If you look at this code and you read it, you see it's very similar to the way you would say it in a natural language. The code takes inputs, generates a list from them, divides the list into tasks, calculates results, and finally publishes those results. This is readable code.